Welcome and hello. This is a video lesson in MODSIM DSS. And in this lesson, we're going to be talking about link properties, losses, and routing, sometimes referred to as channel losses and channel routing. All right, so let's go ahead and get started. What I have on the screen is my MODSIM DSS user interface. And I have a very simple model schematic sketched in here with two non-storage nodes and one consumptive demand node. The nodes are labeled 1, 2, and 3, and then you can tell by the arrows or the links here that the direction is from 1 to 2 and then 2 to 3. I'm going to start by opening up the properties of this first link right here, link 1, 2. And actually, yeah, I think you can double click or right click in properties. That'll open up the properties box. The name of the link, I just sketched it out. It's right here. It's 1_2. So I think the default name is just the upstream node underscore the downstream node, but you can change that. You can also provide a description, but that's optional. And then for the link type, that is going to be standard apparently. All right. And then below that, we have tabs for general, advanced, and measured flows. Now, in this particular lesson, I'm only going to talk about the general tab as well as the two other tabs associated with losses and routing, which will appear when we select channel loss and channel routing from this channel type dropdown. So I sometimes interchange the usage of the word link and channel and arc. Just so you know, I'm referring to the same thing. It's basically the connection between nodes. Okay, so we're going to start with default and just talk about this tab first. The next item down is to specify the link cost. So I could type in a cost of 5, for instance. I'm just arbitrarily setting a cost. So the objective function would take into account the cost of flow through this link when determining its least cost routing. So for instance, if you had a parallel pipe structure and then two of the pipes or links in that case had a different link cost, then the algorithm would route all the flow through the link with the lower cost. Down below that, we have capacities. We need to set the minimum and the maximum values. And before that, we have this checkbox here that says seasonal capacity. So if you check on the seasonal capacity, that constrains the link to an annual maximum total seasonal flow. Once the accumulated seasonal flows exceed the maximum seasonal capacity, the link is effectively turned off and no further flow is allowed through that link for the remainder of the current season. So I'm going to just leave that off. I think I'm going to tackle this in a future lesson or exercise, but for now, I just wanted to explain what it was. All right, next up is the minimum rate, and the default value here is 0. This refers to the minimum flow through the channel. So it makes sense that it would be non-negative, but it also makes sense that it's exactly 0 because if it's like a river reach, for instance, then it makes sense to say that it's 0 because physically it can be 0. You can literally have a dry riverbed. Now you may have some sort of in-stream flow demand that would be penalized if it's not met, but there's other ways in the model to set that minimum in-stream flow demand, not by setting the physical minimum of the channel flow or the link flow to something greater than 0. So I'm going to go ahead and just leave that at 0, and most always will. This is considered a hard constraint, and one of the most common errors in MODSIM is infeasibility, which is caused by link constraints being too small, too narrow, such that there's no feasible solution. So definitely going to leave that at 0. And then down below here, we have to set the maximum rate right here. This is the maximum flow through this particular link. Now, unlike the minimum rate or the minimum flow, which is just set to a constant, the maximum has a lot more flexibility. So for instance, we can change this value. The default value is in like 30 million or something, 30 billion. We're going to go ahead and change that. I want to just point out that this M/D, I'm pretty sure should be down at the next level, next to the start date, referring to the month as 01 / the day 01. So that's just telling you that the month comes before the day in this format. And then there's the time of day in case your time step is that small, is less than a day. But right now it's just setting that the maximum allowable flow through this link is some 30 billion, which is absurdly high. So let's go ahead and change that. In fact, what I'm going to do is click OK. I'm going to delete this link. So right click, delete, and then I'm going to come up to my defaults. So go to MODSIM menu and then network settings. And then down here towards the very bottom, we have default max link capacity. And there's that number again. Let's just set it to like 2500 and then click apply, click OK. Now I'm going to sketch in a new link between nodes 1 and 2. And remember to sketch in the direction of the flow. Last lesson, I was actually confused about how to move the node versus how to sketch a link starting from that node. And the difference is if you want to move the node, you want to put the cursor at the very center of the node icon, and that's how you pick it up and grab it with the holding down your left mouse button. But if you want to start a link from that node, you want to grab it sort of towards the edge of the node, but not the very center. So if I want to start a link, boom, there we go. Just voila. Okay, let's go ahead and check out the properties now. Right click on that new link, properties, and then down towards the bottom, we see our default max flow through the length of 2500, which is what we just set. So if we just leave it as it is, this is going to be year round, year after year. If we wanted to vary it by the year, we could change this checkbox here. I'll get a dialog box that tells me, oh, hey, by the way, the data that you have saved is going to be overwritten. I'll say okay. I didn't have anything saved there anyway. And now I can specify the year. So we have M/D/year. So that's the format there. But this is only a 1 year simulation, the default project. So I'm just going to go ahead and switch that back so that the values will repeat year after year. So the maximum is 2500. Let's go ahead and set it to, how about 2000 for January 1st? And then let's click apply. And then let's take a look at the plot. Okay, this is the plot of the maximum flow through that link, and it's for the entire year, and it's a constant 2000. If I go back to the data now, and I set the units to something different. So say, for instance, instead of 2000, what was it, acre feet per month, I set it to cubic feet per second, and I change it to 100 CFS, and then click apply, and then click on the plot. Now the plot looks a lot different, and the reason is because of unit conversion. So we typed in a constant, what was it, 100 CFS data? Yeah, 100 CFS is the maximum allowable flow through that link. That converts out to units of acre feet per month. It's kind of hard to read, but this vertical scale here, if you turn your head sideways, you can see acre feet per month. Because in 1980, February only had 29 days. January had 31, same with March, they always do. And then this is representing April and June, 30-day months. If I click on the bar chart, you see it goes up and down based on that month. So don't be confused by this plot. If you want to actually see the numbers, you can click on this view data table right here, and it pops up with the actual values, which appear to range between around 6,000. And then it's significantly less in February because there's just fewer days that month. If I wanted to actually change the maximum flow rate in CFS halfway through the year, for instance, I can just click down here on this table, add a new value. So instead of 100, maybe we'll say 50. And then that could start in February and it could go for the rest of the year. Or I could change it and maybe just toggle up to July. So starting in the second half of the calendar year, that's when the max flow rate is 50 CFS. So if I click apply and then I click on the plot now, here we have the flow rates ranging closer to around 6,000 acre feet per month. And then starting in July, it's closer to about half of that, closer to around 3,000 acre feet per month. Now the little deviation for February is less pronounced because of the massive drop in the second half of the year. And then we can again change the units back to acre feet when we input that data. So let's just go ahead and do that per month and apply. And then if I look at the plot, it's just a straight line, 100 up here and then 50 down here. If I click on the bar plot, well, that was the line plot. Here's the bar plot. I kind of wish that they would extend the vertical axis a little bit more just to make it easier to see. But anyway, okay, so that is my discussion on the general tab. Next, I want to talk about channel losses. So I'm going to come up here to this link channel type, and instead of default, I'm going to change this to channel loss. And notice that there's a new channel loss tab that appeared right here. For a channel loss coefficient, I'll just type in 0.03. This value represents the fraction of flow at the head of the link that is lost during transition through that link. And then on page 60 of the user's manual, you have this diagram right here. So for instance, if node n represents node 1 and then node n plus 1 equals node 2, the next downstream node, Since MODSIM uses a network flow, what it does in the background is it creates this artificial node GW representing groundwater and an artificial link that goes from node N to the GW node, the artificial node, through an artificial link so that some of that flow is actually routed not to node 2, but rather to the artificial node where it stays and can possibly return to the network. In the case that it was just subsurface flow, it returns as surface flow later on. Or it could be lost to like an aquifer deep storage and be completely lost from the system. The way MODSIM calculates channel losses is it first assumes that there's no channel loss and then that the channel loss is then calculated. So we have lower bounds here of 0 and 0. This particular notation is the lower bound of the link, the upper bound of the link, and then the cost. So the cost 0 right here just represents 0 cost for losses. And then after the first iteration, whatever the calculated losses are, that is updated to be the next iteration's lower bound and upper bound. And then the model is run again and again and again. And eventually these losses that were assumed are going to equal the losses that were actually calculated by the model. And that satisfies the convergence criteria for calculating that particular loss in that channel. Okay. So anyway, the user's manual has some equations and talks about how that works. Once the losses are calculated in iteration k equals the losses calculated in iteration k minus 1, the model has converged. All right, so that's how that works. Also, there's this return location node. Like I mentioned, the losses return to another downstream node. You can specify that in this dropdown right here. You'd have your list of nodes just listed out. If you're interested in looking at all of the link data in your model, or at least a subset, multiple link data at the same time, we can't do that by looking at the property box that I have open here. But what you want to do is go up to the MODSIM menu and then click on cost analysis. And then in this box, click on links. That opened up this dialog box, which doesn't need to be this wide. So let's resize that width. We have the different links in our model. We have 2, 3, and 1, 2. It shows the number. I think this is just an auto-generated ID. And then the type, the cost, which I don't think I saved that. And then a couple other columns here that are associated with water rights and storage accounts, which we'll discuss later. But anyway, we can look at all the links and their cost and type right here from this box. So if I wanted to set the cost of 1, 2 to, let's set it to something different like 7, and then click OK. Let's go back and check out the properties. Oops, there we go. Right click properties, and then boom, we have the 7 right here. But if I change it to 8 and then click apply and OK, and then come back to the MODSIM menu and then cost analysis, and then click on links, right here is the 8, that cost that I just put in. Okay, let me move that over again. This dialog is also pretty helpful to use this filter option. There's a filter and it gives you a few examples, or you can just type your own using the specified format, where you just basically type in what is essentially a where clause in a query if this is your table, and say your cost is one of the fields that you want to include in the query. You have a couple of these defaults. So you just put the field name in brackets and then your operator greater than, less than, equal to, and then the value. So in the case of cost being greater than 0, if that's the value I want to put here for my query, I just click apply and then boom. Now I'm only seeing that link 1, 2, which has a positive cost. Next, I'm going to talk about the link routing. So let me go right click, open up our properties box again for link 1, 2. We're picking on this link. And then instead of the link channel type being default or losses, now let's check channel routing and then click apply. Okay, I must return a select node. I think that's because channel routing has this return node right here. So we have a channel routing tab that popped up and I selected it. And then the routing basically is going to route water from node 1 to node 2, but there's going to be some sort of attenuation applied to the water, so there's a delay. Channel routing may be necessary for smaller time steps, such as daily stream flows, or even sub-daily, like if you had an hourly time step, that's possible in MODSIM. But if your time step was monthly, then you probably wouldn't be using channel routing. Now, our options to specify the lag factors are either user generated or calculated by the model using the Muskingum routing parameters here it's kind of grayed out because I have user generated model selected. Inflow in this link is distributed over time in accordance with the routing coefficients, either calculated by the Muskingum formula or by user routing coefficients and lag factors. So let's go ahead and show you where that's controlled. For instance, if I had my lag factors already known, I could just type them in here. So here's some typical values from the user's manual, where C sub 0 is 0.25, that's flow in the same time step. 0.5 would represent 50% of the flow delayed one time step, and then 0.25 would represent two time steps delayed for a sum of 1. Again, this is the flow from node 1 to node 2, and you need to keep in mind that the time step is set in the program settings. So let me go back. Oops, I still need to click a return node. So let's just say 2, since this is from 1 to 2. So I'll click apply. I'll click OK. Something I'd also have to change is the time step. Like I said, daily or sub-daily. So I come up to the MODSIM menu, network settings, and then on the time step tab, it's currently set to 1 month. So if I set that to say an hour or a day, that should work. We'll click apply and OK. Let's come back here to edit the link properties, move that over, and now the channel routing tab is moved over adjacent to the general tab. That's fine. So that would make more sense if we had a daily time step. All right, so let's go ahead and now toggle on the model generated lag factors. To do that, you're going to go up to MODSIM network settings, and then it's right here for lag factor type. It was user generated. Now it's going to be model generated. And here's where I can specify the number of factors. So yeah, let's change that to 4 just to notice a change. I'll click apply, click OK. Now let's check out those link properties one more time, and then click on the channel routing tab. Now I need to specify the Muskingum X value, the Muskingum K value, and then the number of subreaches is just assumed to be 1. The X value here is called the weighting factor. It's a dimensionless number between 0 and 0.5, representing the relative influence of the inflow on the storage volume. So a value of 0, if I just left it there, would basically be like a linear reservoir. But if it was the maximum of 0.5, that would represent the maximum attenuation. And then the Muskingum K value, this represents the travel time through the reach, and it's also based on the time step. Remember, our time step is 1 day, so I'd have to specify the number of days that the flow takes to travel from node 1 to node 2. It's kind of grayed out here, but you can see the word day written down here in Muskingum. This is the number of subreaches. It's just fixed to 1. The user's manual has the equations for the coefficients on Muskingum. And then here's the K value and the maximum and minimum values based on delta T, that's for us 1 day, and then the value of X, which is ranging from 0 to 0.5. So for instance, if your DT was 1 day and then your X value was, say, 0.25, then K would have to range between 2/3 and 2. So just so you know that the K has to be in a certain range there, otherwise you'll have negative coefficients. I should probably also mention that on page, let's see, 64 of the PDF file, we have this general equation that demonstrates the calculated flow based on routing. So it takes those routing factors, C0, C1, C2, whether they're user input or generated from the model, and then the flow rates in the current time step and the previous time step. That way they know how much flow actually goes from node 1 to node 2, whether the flow entered node 1 at that time step or at a previous time step. And hence there's that delay by rerouting through an artificial node. Speaking of which, there's a separate diagram to demonstrate that at the top of page 67, and here it is. So if we had node 1 and node 2, or n and n plus 1, if we introduce routing, the network flow looks sort of like this. We introduce an artificial node, n prime, which routes the flow to another artificial node, GW, through an artificial link, whose initial minimum and maximum values are set to 0, just like the losses. And then with each successive iteration, the minimum and maximum values are set to the same number based on the previous iteration's calculation for that routing. So after enough iterations, the actual flow through this artificial link to GW is calculated, and then that's what the model settles upon. Similarly, we have a flow from GW back into the downstream node. So I think this dashed line right here should actually be coming from the GW artificial node, but it's going to be entering the next downstream node. And again, the flow rate into this downstream node is the sum product of the coefficients and then the flow entering the upstream node at previous time periods, which is again this equation right here. Well, that's all I had for this lesson. What we talked about was links, link properties, and also losses and routing within the link or the channel in MODSIM DSS.